everybody, in this video I'm going to start introducing the notion of biconditionals, and we're going to take a look at two rules that we can use with biconditionals: biconditional construction and biconditional elimination, or double arrow in and double arrow out. Let's get into it.
We've talked about conditionals, we've talked about conjunctions, we've talked about negations. What are biconditionals? These are if and only if statements, which are represented by the double arrow. So let's go ahead and talk about these and what we do with them. I actually think biconditionals are easier to deal with than negations. But let's see what we've got. Biconditionals are represented by the statement if and only if. So here's what a biconditional looks like. A double arrow B. So when we see a biconditional, we can represent it by the phrase if and only if. We can represent it by the phrase necessary and sufficient condition. Conversely, we can represent it by saying sufficient and necessary condition. Both of these kind of give a hint as to what it means. And then two other weird phrases that don't pop up in English very often, but we're going to use them anyway. Just in case, and then also exactly if. If we're going to get real British, we can say precisely if. I'll put that one there too. So all of these, if I had A double arrow B, it's the same thing as saying A if and only if B. It's the same thing as saying A is a necessary and sufficient condition for B. It's the same thing as saying A is a sufficient and necessary condition for B. It's the same thing as saying A just in case B, A exactly if B, and A precisely if B. And also, I'm going to go ahead and say here vice versa. The way the double arrow works, it's basically saying that the arrow works in both directions. What you're saying here is this is a well-formed formula that's saying the shorthand, and so I'm going to say we can say it's the same thing as saying A leads to B and B leads to A. In other words, the arrows lead into each other, hence whatever follows if, remember, goes on the left side of the arrow, but then I said if you see only if, draw an arrow right over it. What's going on here is it's saying the arrow goes in both directions. One thing leads to the other. Let's take a look at what I mean by this. And so these are all the phrases that we could use to represent the double arrow. And the double arrow means that, hey, A is leading to B and B is leading to A, which means A double arrow B is actually the same thing as saying B double arrow A. The order doesn't matter. One thing's leading to the other. That's all. And vice versa. That's what it means. So let's take a look at that. To explain the notion of biconditional, a double arrow, I'm going to take two statements here. I'm going to call this one S1. I'm going to call this one S2. And one of these is true and the other is false. That is, one of them works and the other doesn't. So let's see. A shape is a triangle if we see IFF like this. That's another way of saying if and only if. It's a necessary and sufficient condition. It's a sufficient and necessary condition. Just in case, precisely if, exactly if. It means the same thing. Okay, it's another stand-in for the double arrow. So this says here, a shape is a triangle if and only if it has three sides. What does that mean? Well, T, and then the if means double arrow, S. This means if a shape is a triangle, it has three sides, and if a shape has three sides, then it's a triangle. Is that true? Yeah, it is. Let's take a look at this one, though. So this is true. This checks out. The double arrow here is legitimate. Let's take a look at this one. A shape is a square if and only if it has, and I'm going to say 4 here, so we'll do F for 4, if and only if it has 4 sides. So let's take a look at this one. This one would say, I'm going to go ahead and say it's false, but this one would say you got a square if and only if you have 4 sides. Here's the problem. If you've got a square, does it have 4 sides? Does that check out? Yeah, that one does. If you've got a shape that has 4 sides, is it a square? No, that does not check out, because you could have a rectangle, you could have a diamond, you could have a quadrilateral of some kind. So this does not work this way. So this is not an if and only if statement, like in reality. It doesn't work. So if and only if works if it means the same thing both ways. So if something's a triangle, it has 3 sides. If it has 3 sides, it's a triangle. If it works both ways, you can say, hey, it's a triangle if and only if it has 3 sides, which is the same thing as saying it's got 3 sides if and only if it's a triangle. You can say it either way. This does not work. It doesn't work in both directions. This works one way. All right, so that's why I said this one does not work. If a shape is a square, then yeah, it totally has 4 sides. But if a shape has 4 sides, then it might be a square. So the fact that it might be something else, it might be a diamond, it might be a rectangle, it might be a quadrilateral, for example, it might be a trapezoid. It doesn't work this way, so it's not an if and only if statement. So if and only if statements or double arrows are kind of ways of stating definitions. You're saying this thing leads to this thing, and this thing leads to this other thing. back and forth. Think about back what I said on quiz 1. I said an argument is valid if and only if. It's a double arrow. The premises are true, then it's impossible for the conclusion to be false. What does this mean? Well, since it's a double arrow, what it's saying is here, this definition works in both directions. If an argument is valid, then if the premises are true, then it's impossible for the conclusion to be false. It means that, and if the premises are true, then it's impossible for the conclusion to be false, then the argument is valid. What it's saying here, the argument works in both directions. That's what a double arrow is and means. Again, it's shorthand for saying this. If you got this, and you got this, the arrow goes in both directions. That's the same thing as saying A if and only if B. It's the same thing as saying also B only if A. It works in both directions. That's precisely what the double arrow means. And so that leads me to two rules that we can use with double arrows, with biconditionals. The first one that I'll talk about is the notion of double arrow out. And so what this one says is if you have a double arrow, let's say we got this, A double arrow B as an assumption, that breaks down into if A then B and if B then A. And that would be double arrow out on line 1 for both. It's saying, the double arrow is saying this leads to this and this leads to this at the same time. So again, a double arrow is just a shorthand version of saying this. A leads to B and B leads to A. But the well-formed version of saying this would be this right here. So this is one rule we've got, double arrow out. If you got a double arrow, it breaks down into the arrow going in both directions. That also leads us into the next rule, double arrow in. Double arrow in is the exact same rule, just in reverse. If I have this, if I have A arrow B as an assumption, and I have B arrow A as an assumption, that means I can get A double arrow B. How? Double arrow in lines 1 and 2. But also, not only this, the direction in the double arrow really doesn't matter. So I could also get, if I needed to, B double arrow A with the exact same reasoning. I'm going to switch it up a bit. I'm going to say 2, 1, because if the B came first, I'm going to follow 2's lead. So this is double arrow in. If I have an arrow and I can see like A leads to B, B leads to A, that's the same thing as saying A double arrow B. It's also the same thing as saying B double arrow A. So I'm going to put which one of these I need to. I'm going to build which one I need to, depending on the situation. Let's take a look at a couple of examples of that. So this says, Madeline moves to Columbia if and only if she does graduate work. What would that be? Line 1. She moves to Columbia if and only if, so double arrow, she does graduate work. Assumption number 1. And then it says, so, which means, here's what we're solving for. So, prove this. She does graduate work if and only if she moves. And so in a certain sense, these are logically equivalent insofar as just like A dot B and B dot A are equivalent. But just like there, we need to say how we get from one to the other. We have to do the same thing here. And it's not with and outs, it's with double arrow outs and ins. So let's see if we can do it. Here's what we do in this situation. With double arrow out, if you got a double arrow, what that means is you can turn it into an arrow going one way and the arrow going in the opposite direction. And then double arrow in is if you have an arrow where you've got like something like this, like A arrow B, and you've got B arrow A. You can put those together. Here's what we do in this scenario. Do we have a double arrow? Yes. If you got a double arrow, go ahead and get it out. So one of the arrows is going to be the exact same thing, but instead of a double arrow, you've just got a plain arrow. So that's double arrow out on line 1. And then you're going to get the exact same thing going the other way. So we also get G arrow M. That's also double arrow out on line 1. So what this is saying is Madeline moves to Columbia if and only if she does graduate work. It's the same thing as saying if she moves, then she's doing graduate work. But also this other thing, if she's doing graduate work, then she's moving. We did that from double arrow out. But double arrow in also says if you got two things going, like this thing leads to this, and the other thing leads to this. So look at this. So M here is the sufficient condition for G, but also G is the sufficient condition for M. That means M is a sufficient condition for G, and it's also a necessary condition for G. That's why we can also say double arrows means something is a sufficient and necessary condition. I could also say G is a sufficient and necessary condition for M. So that's why we can get the double arrow. So what we're doing here, the goal is, say, G double arrow M. Well, this just means we can recombine these things in a new manner. We can say G double arrow M, double arrow in. Where do we get those pieces? 2 and 3. We could also say 3 and 2. In fact, I would probably do that just to follow the lead of whatever letter's in play, but it's right the other way too. So here we go. That's how we do a problem like this. Let's take a look at this argument. The government may restrain the publication of news if and only if it may compel the publication of news. What would that be? As it's given, and again, you have with double arrows, you have the option of putting it in either direction. Do it in the way that it comes. So I'm going to say here, line 1, R double arrow C. That's what we got. It may restrain if and only if it may compel. The government may, no, notice here we got a not, may not restrain the publication. So the government may not restrain publication. Assumption number 2. It clearly follows that it is also not permitted to compel the publication of news. Let's do it. And here's what we have in play now. This is what I want to stress. We've got, first of all, can we do an arrow out? Can we do a modus tollens? And now this is new. Can we do a double arrow out? Can we do a double arrow in? And then the stuff that we did before. Can we do an and out? And then can we do an and in? Can we do a double negation? And then emergency case scenario, can we do an arrow in or an indirect proof? So here, do we have an arrow not in parentheses? No. So we can't do arrow out or modus tollens. So I'm going to say right now, don't mix up arrows and double arrows. Don't do it. So no, no. Do I have a double arrow not in parentheses? Yes, I do. So what should I do now? Break that down. That gets you 2 things. You get R arrow C, and you also get C arrow R. Both of those are double arrow out on line 1. Now, can you do an arrow out? Okay, do we have arrows not in parentheses? Yeah, we got 2 new ones. This one and this one. Left side matches? No. Do we have any right side contraries? Yes. Look, we have a contrary between line 4 here, C arrow R, and look, its right side is R, its contrary is squiggle R. So that means we get squiggle C. How so? Modus tollens, 4 and 2. Let's take a look at this problem here. We got D arrow E, and we have separately E arrow D, and we want to get D double arrow E and E double arrow D. This one's ridiculously easy, but doesn't look like it from first glance. So first of all, can we do any arrow outs? We got 2 arrows not in parentheses, arrow outs, DE, left side matches. Right side contraries, squiggle E, squiggle D, no. Can we do a double arrow out? No. Can we do a double arrow in? Yeah, in fact we can do 2. And look, what we're going for, now the last move in this problem, we're going for an and this has been true for a while. If you're trying to get a dot, the last move is going to be an and in. And 100% guaranteed, the last move in this problem is going to be an and in. But if you're trying to get double arrows as well, odds are you're probably going to do a double arrow in. So look at this, D double arrow E. Do we have the pieces to build it? Actually, yeah, look, if D leads to E and E leads to D, that means that's the same thing as saying D double arrow E. How so? Double arrow in, line 1 and 2. Now look at this, that's one of them. The other one is the exact same thing, just switched around. Do I have the pieces to build it? Actually, yeah. I can get E, double arrow, D. How? Double arrow in, and I'm going to say here 2 and 1, just to follow the lead of the E. But it's the same thing. I could use the same numbers to be fine. So look, I have the 2 pieces. These are 2 things I need. What do I need to do? Just add them in. D double arrow E and E double arrow D. How to get it? And in 3 and 4. Problem is done. So this one we got this. A double arrow B, A. So your immediate visceral response might be, oh, I've got a left side match, that leads me to B, bam, I'm done. There's a way to do that later on with another move, but based on the moves we know, this is not a left side match because that's not an arrow, this is a double arrow. So do we have an arrow not in parentheses? No, so we can't do an arrow out modus tollens. So we have a double arrow not in parentheses. Yeah, so what does that do? That breaks down into 2 things, A arrow B and also B arrow A. So here was our first assumption. This was double arrow out on line 1. And this was also double arrow out on line 1. Okay, now I've got 2 sets of arrows. Line 4 I actually don't need. Do I have a left side match now? Yeah, between 3 and 2. What does that get me? B, which is what I was after. How did I get it? Arrow out, not between 1 and 2, but between 3 and 2, because the arrow out, use the arrow here. You can't use arrow outs on double arrows.
So that was a bit of an introduction to biconditionals. What I'm going to do in the next video is we're going to start doing some practice problems with biconditionals. See you next time.